The idea of tonight's stream is, by no means to replace actual tutoring, but to give students a taste of the ACT math section. Absolute value, make sure that you simplify the inside of the absolute value brackets, I'll call them, first, before doing, before making whatever's negative positive. So that is not 6 plus 4. That's 6 minus 4, which is 2. So we're going to get absolute value of 2 minus the absolute value of 3 minus 8 is negative 5. So that's going to be 2 minus, the minus isn't going to change, positive 5. And that's negative 3. And I've definitely seen that one before. But I promise I'm not cheating here. Yeah, so that's G. Cool. So this is now number 6. Of the 180 students in a college course, 1/4 of the students earned an A for the course. Cool, I'm going to start writing this down. So, let's make a table. 180 total. Okay, sorry. I have a tool for this. Let's make it pretty. And I'm actually going to, I'm going to do something like this. I already have a suspicion of what this is going to look like. So I'm going to put 180 down here because that's the total. 1/4 of the students earn an A. So A, B, C. It looks like they're just giving us that. Yeah, A, B, and C. So A, B, and C, that's 1/4. 1/4 of 180 would be 45. I do math for a living, so I can do quick mental math. If you're not 100% sure, break out the calculator. Nothing wrong with that. B was 1/3. That's 60. So now we have 105. So again, this is why I'm setting it up this way. This is a little bit extra. But this is a tool that you can use if you're ever not 100% sure what you're doing on a problem, you don't know where to get started. As soon as you realize that they're giving you, A, B, C, fractions, and then you have a number for what it actually represents, organize the data. So the rest of the students earned a C for the course. Okay, well, I don't know what that's going to be in terms of a fraction. I'm not gonna figure out I'm not gonna get a common denominator. 3/12, 4/12. That's 7/12, and then 5/12 is what remains. I'm not going to do it that way. That's one of the ways that you can solve this problem, and I just did it. So this would be 5/12 right here. But, and we can just do 5/12 of 180. But as I said, I think the easier way is add these up. That gives you 1 of 5. What remains would be 75 to get up to 180. So that makes sense to me. And then, if I were being really cautious, which again, that's sort of what I told you I will be doing tonight is being really cautious. I'm just going to go ahead and give me a moment. There, calculator on top. I'm going to find out if 5/12 of 180 is indeed, so 5/12 times 180 is 75. And so, cool, I'm very confident in my answer. The answer is going to be F. Yeah, as I said, the right answer will be F. There we have it. That's all there is to it. Right off the bat, I see an equation. So I see f of x equals 3 times 2 to the x. Cool. I'm going to now look at the question, which is, according to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? All right, so I see that they have a few examples here. X equals 0 for 2000. X equals 1 for 2001. So what I want to notice is that x is equal to the last year, so 0, 1. So that means that x is going to equal 6 for 2006. They want to know, according to the model, how many fish were in Skipper's Pond at the beginning of the year 2006. I'm going to assume I just have to plug in 6. This number 7, it shouldn't be a hard one yet, so I'm not too worried about it. 2 to the 4th is 16, 32. I think that's 64. I'm doing mental math, which really I want to encourage students not to do ever. 3 times 64 is probably 192. I feel pretty comfortable with that. So that means that the answer would be B. Let's see if, let's see if doing mental math ends up hurting me, and it doesn't, though it might hurt you. On test day, there's no reason to take shortcuts. There's just no need to. This is geometry, specifically a similar triangle problem. And that's really significant. So this is like, I think that there's one of these on every test in some capacity. So it's important that you know how to do these. So what I want to point out is right off the bat, I'm just going to look. I know exactly how to do this problem. I know exactly what they're asking. So what is the length of AC? Note that it's this. Note that it's this whole thing, that whole side that we're trying to find. In order to do that, I need to find this whole side over here. I kind of missed it up there, but oh well. And that whole side would be 15 plus 6 is 21. And then what I want to point out is on this smaller triangle, so on just this little guy right there, 8 times 2 is 16, and that's from the left side to the right side. That pattern holds up for what we're about to do, which is 21 to whatever this is. This number right here is going to be 2 times 21, so 42. If that's not clear, I'll write it out like the appropriate way, and I'm going to stick to my color coding. So the stuff that isn't color coded is 8 and 16, and then as I said, it's going to equal. Let's see. So do you notice how 8 is on the left hand side of the triangle, and it's on the top here? Well, that means I want 21 to be on the top on the right hand side. Basically, on the left hand side here, we have the smaller triangle. On the right hand side, we have the whole triangle, and then on the top we have the left. On the bottom, we have the right. So that's going to be, you can write x and then solve that equation. But as I said, I know that it's just going to be twice. So it's going to be 42, which, great. Now we can go check that answer. That's going to be D as in delta. Cool. Almost 1/6 of the way through. That's exciting. Okay, Katerina runs 15 minutes in 2.5 hours. Man, fractions. They love to throw fractions at you in any way, shape, and form they can. So right off the bat, I'm going to note that, hey, we got some fractions going on here. It also looks like we're doing a unit conversion because I noticed that they're emphasizing, hey, what is the average number of minutes it takes her to run 1 mile? And so essentially what I'm going to do, if you've taken chemistry, the term stoichiometry might ring a bell, might not. I have not taken chemistry in a while. So I think that it's stoichiometry, but I also think that dimensional analysis is the better term, but those might be synonymous. Either way, if you've taken chemistry, this might ring a bell. It's way better. So yeah, sorry, just to recap. If you've taken chemistry, this might look familiar, but what I'm going to do here is I'm going to say, all right, it's 15 miles in 2.5 hours. What I'm going to do is I'm going to multiply that by something over something, and it's going to be a conversion that I'm going to come up with now. The conversion is, they want to know the number of minutes it takes her to run 1 mile. Okay, well, let's, oh man, there are a few things going on here. So first things first, I want to just make that conversion. So I have 60 minutes per 1 hour. Notice that the 1 hour is on the bottom here. I'm going to actually flip that around to 1 hour per 60 minutes. Because what I want to do, and this is why I was referring to chemistry a moment ago, is I want the hours to cancel out. You gotta have it on top and bottom for it to cancel out. So boom, cancels out. And what that means is that we can do 15 miles divided by 2.5 and then divided by 60 again. And that's going to give us basically some number. And I'll do this work now really quickly. Let me just move my calculator over. I'll put it a little bit lower. So I'm going to do 15 divided by 2.5. It gives me 6. And then, so what that means is 6 miles per 1 hour. That's what that 6 means. But now we're going to do the conversion with minutes. So divided by 60, that means 0.1 miles per minute. So it's important to know what you're doing and why. So 0.1 miles per 1 minute. Now what they asked is how many minutes does it take her to run 1 mile? So what I'm going to do is I can flip that. If it's 0.1 miles per 1 minute, that means it's 1 minute per 0.1 miles. And if I divide that, so 1 divided by 0.1, 1 divided by 0.1 gives me 10. Again, what that means is 10 minutes per 1 mile. Whenever you do a division operation, technically what you're doing is you're reducing the denominator to 1. So that's sort of what I'm taking advantage of here. Another way of looking at this equation right here is that I just multiplied the top and the bottom by 10. Remember that you can multiply anything by 1, and technically we're multiplying this by 10 over 10, which is 1. So 10 times 1 is 10, 10 times 0.1 is 1. So again, it's 10 minutes per 1 mile. Give me 1 moment. There we are. And that's that. So let's check that answer. I didn't get the letter G. All right, cool. First 10 right. Love it. So not that I expected anything different. I'm not surprised. Just, there's a part of me that's like, oh man, hope I don't mess this up. Number 14 is the next one that we're looking at. Flying through these. It's crazy to me that it has been 45 minutes. Here we are. Okay, so number 14. At Sweet Stuff Fresh Produce. There's a lot going on here. Okay, so the price of a bag of grapes depends on the total number of bags purchased at one time, as shown in the table below. In 2 trips to Sweet Stuff this week, Janelle purchased 3 bags of grapes on Monday and 4 bags of grapes on Wednesday. How much money would Janelle have saved if she instead purchased 7 bags of grapes in 1 trip? Okay, so they want you to do 2 calculations. Again, this is what I mean when I say like multi-step problem. They love to make you do this. So I'm gonna note what that problem type is, and then there we are. So first things first, how much did she pay already, which is 2 trips, 3 bags on Monday. So 3 times 3 is 9, plus 4 bags on Wednesday. 4 times 2, 80 is, I'm going to break out my calculator. 4 times 28, I don't know, 100 plus 12, 112. I'm going to say 1120. It's my guess. Heyo. All right, 1120. How much money would she have? Okay, so that's how much she spent doing 2 separate trips. So that's 2020. Hindsight's 2020, Janelle. That's her name, right? Can't find her name all of a sudden. There it is. Okay, so 2020 is how much she spent Monday and Wednesday. Now we have to find out how much she would have spent if it was 1 trip. Well, 1 trip would have been 3 plus 4 is 7, so it would have been 7 times 260, which again I'm going to break out my calculator for. So 7 times 260 is 1820. So 1820. I'm going to refashion this as a, oh, you can't see because of the calculator. I'm going to refashion this as 2020 minus 1820 is going to be $2. So how much money would she have saved? J. Make sure that you know what they're asking for. That's the biggest danger with these problem types, is they're throwing something at you, or they throw a lot of information at you. You have multiple steps. They're not asking how much did she spend, or how much would she have spent if she did it in 2 trips or did it 1 trip. They're not asking how much did she actually spend. They're asking what's the difference. So always make sure that you know what the difference, or what it is that they're asking. The easiest way that you can go astray here is by ignoring that. In right triangle ABC shown below, the given lengths are in millimeters. What is sine of A? Okay. So the millimeters is totally to throw you off because they don't even use it. This is SOHCAHTOA. You need to know SOHCAHTOA to tackle this. Yeah, I think it's kind of straightforward. They're saying, what is sine of A? So sine is, sine means that sine is, sorry, that's really vague. That shouldn't be an equal sign. What so means is sine is equal to opposite over hypotenuse. If you're not familiar with that, you should familiarize yourself with SOHCAHTOA and practice that. But what that means is that from A, our opposite is 7. Our hypotenuse is always going to be the actual hypotenuse. So it's just going to be 7 over 9, which would be D. It's that easy if you know what you're doing. So boom, and now we can move on. Okay, so 21. This problem might look really scary. There are a lot of things going on here. It's obviously a geometry problem. We got some triangles going on here. We also have a circle. But I think that the biggest thing that they're going for here, is they're trying to confuse you with this vocabulary. So let's tackle this. The big thing that I want to point out, and this is you'll see this in a lot of other problems too, but the big thing you have to notice that this is a radius, this is a radius, this is a radius, this is a radius. So on the triangle on the left, we have 2 radiuses, and then that internal angle is 60. That has to be an equilateral triangle, because if these 2 sides are both the radius, that means that they're both equal. That means that the angles opposite them are also equal. Well, that means that this right here equals this right here, and in the equilateral triangle, all the sides are equal. Logically, it has to be. Let me say, I'm not doing a sufficiently thorough job of explaining this. So 60 plus 2x equals 180. 2x equals 120. X has to equal 60. So mathematically, that's just how it has to be. And you might have like a vague itch that yeah, that seems right. But again, logically, I just want to prove it. Now over here, we don't have the same situation. Since that's 90 degrees, that's an isosceles triangle because we have 2 equal sides. But this guy right here is a different length from the other 2. So right off the bat, which does not appear in the triangle or in the figure, well, we definitely have an equilateral. We definitely have an isosceles. We definitely have a right triangle. So now it's acute or scalene. I'll be honest, I don't know what an acute triangle is. However, I do know that 60, 60, 60, all those are acute. So it's probably an acute triangle. I don't know if an acute triangle is one side's acute, which, again, I feel like every triangle has to have at least 1 acute side, so it's probably not that, or 2 acute sides, but it has 3. I don't know what else you would call an acute triangle if it's not all 3 sides are acute. So E is the last one. And that's scalene triangle, which means that none of the sides are equal, and that's just false here. One side of a square has a length of 12 meters. Well, that means that all sides have a length of 12, because it's a square. A certain rectangle whose area is equal to the area of ABCD has a width of 8 meters. Okay, so they love to do this, and I haven't found a good way of talking about these problems or describing, like classifying them. But essentially, they love to do this thing where they say a certain rectangle whose area is equal to the area of ABCD. It's like, okay, cool, well, just stop there. Let's find the area of ABCD, 144. Now what they're telling us is just a certain rectangle whose area is 144. They love to word it that way just to throw you off, but it's important to be able to break it down. So they're telling us that we now have a rectangle, and the area is 144 as well, but it has a width of 8. So they say, what is the length of that rectangle? Well, L, we can solve for L. 144, the area equals length times width, so 8 times L. 144 divided by 8 is going to give us our answer. I don't feel comfortable doing that in my head, I'll be honest. 144 divided by 8. 18. So C. And let's see if that's right. There it is. All right, so that's all there is to it. Again, for that one, it's just, know that middle sentence is the thing. And for now, I'm just going to say area equals area as the answer for that one. But they love to do that. A certain rectangle whose area is equal to the area of ABCD, and then you just have to realize, oh, okay, the area of ABCD is 144. Let's reword that as the area equals 144 of that rectangle. Those were the first 30 questions of the most recent sample practice test the ACT released. Again, I think that that's a really valuable resource. I do want to make a big deal about practicing using official materials. I will take a moment really quickly and I'll show you the book that you should get if you care. This is the book that you want to look for if you are you're going to prepare for the ACT on your own. The official materials are always the best. Any other test, you can't guarantee that it's actually helping you. If you think about it from a very strictly logical perspective, a test prep company selling a book might want you to do worse on your practice tests so that when you take the test, you say, oh my gosh, I'm doing so much better, and then you think that they helped you. Maybe that's not true. I'm not pointing fingers at any specific company, but just again, from a logical perspective, that's something I would be thinking about if I were shopping for tests. Why not just use the official one? And the reason I say that is not because the ACT is above blame, but because the tests that they use here are previously administered tests. These are official tests. So they're tests that somebody took 5 years ago, 4 years ago. The sample I took tonight is basically the same caliber, but we're going to end there. Again, thank you for tuning in. Thank you for your attention. I really appreciate the ability to share my love of math. I'll say it that way, as geeky as it is. But yeah, until next time.